Welcome, dear learners. This is Aishwarya, Assistant Professor, Department of Chemistry, St.Josephs College of Arts and Science for Women, Osur. We are going to see about the acid and bases theory. Acid in water solutions shows some certain properties. It is a taste sour and turns litmus paper to red. They react with metal like zinc to give off the hydrogen. So theories of acid base. The first we are going to see about Arrhenius concept. Arrhenius theory is also called as the water ion system. Acid is a substance that ionizes partially or completely in water to give the hydrogen ions. Example, hydrochloric acid, sulfuric acid and nitric acid. Bases, any substances that ionizes in water to give the hydroxide ions. Example, sodium hydroxide, ammonium hydroxide and potassium hydroxide. So these concept offers the correlating the catalyst behavior with the concentration of H plus ions. The HCl is an acid and NaOH is a base. The neutralization process can be represented by the reaction involving the combination of H plus and OH minus ion. So limitation for this theory. According to this concept, HCl is regarded as when they dissolve in water but not in the solvent. Cannot account for the acidic and basic character in non-aqueous solution. Then we are going to see about the Bronsted-Lowry concept. The proton donor or acceptor system. Bronsted-Lowry in 1923 independently proposed a more general definition of acids and bases. Acid is defined as the hydrogen containing compound that can donate a proton to any other substances. Base is defined as any hydroxyl containing compound that can accept the proton from any substances. Then the Lewis concept. Lewis concept is the electron donor and acceptor system. Acid is the electron pair acceptor, base is the electron pair donor. According to Lewis in 1923, acid is a substance can accept the pair of electron to form a coordinated covalent bond. Base is a substance that can donate a pair of electron to form a coordinate bond. So any substance which has unshared pair of electron, it acts as the Lewis base. While substance which has an empty orbital then can accommodate a pair of electron act as the Lewis base. So according to Lewis theory, neutralization in reaction involves the formation of the new coordinated bond between the electron pair donor and the electron pair the acceptor. In Lewis acid, all the cations are the Lewis acid because they have tendency to accept electron pair. Larger cations of alkali and alkaline ether metal behave as a relatively weak Lewis acid due to their less tendency to accept electron. So limitation for Lewis bases. It does not provide any uniform scale of an acid and base strength. It failed to explain whether the salt formation is behavior of acid and base behavior or not. Normal acid base reactions are fast, but complex formation in terms of donor and acceptor bond formation is a slow. Strong acid bases complete dissociation in water. Weak acid bases dissociate only partially and reversibly. So tables of common acids. Then common table of common bases. Then the conjugated acid and base pairs. So consider conjugated base is a species that remain after an acid has given up a proton. Conjugated acids when a base gains a proton. So in this reaction, HCl donate a proton to the water and therefore an acid water HCl donate a proton to water, therefore an acid. Water on the other hand accept a proton from HCl, therefore a base. In this reverse reaction, equilibrium proceed at the same rate as a forward reactions. So H3O plus hydronium ions donates a proton to chlorine ion, and hence H3O plus ion as an acid, chlorine ion is a base because it accepts the proton from the hydronium ions. Then members which can be formed from each other mutually by gaining the loss or proton are called the conjugated acid base pair. So base is the ammonia, acid is the H2O. So conjugated acid, conjugated base is. So in this example, water first act as a base, then as an acid. Any species which can both accept and receive proton is called amphiprotic, also known as the amphoteric substance. So limitation for the conjugated acid and base pair. The protic definition cannot be used to explain the reaction occurred in the non-protonic solvents such as calcium chloride, sulfur dioxide. It cannot explain the reaction between the acetic oxide and basic oxide which takes place. Substance like BF3, Al3, do not have any hydrogen and hence cannot give the proton but are known to behave as the acid. These are the limitations for the conjugated acid and base pairs. So then the pH scale. The concentration of the ions in solution is very important for living. Low pH correspond to high hydrogen concentration and vice versa. The concentration of hydrogen ion is commonly expressed in terms of the pH scale. A substance that when added to water increase the concentration of hydrogen ion is called the acid. A substance that reduces the concentration of hydrogen ions raises the pH is called a base. Measure the degree of acidity 0 to 14. So most biological fluids are range from 6 to 8. A small change in pH actually indicates the substantial change in the H plus and OH minus ion concentrations. When the concentration of H plus ion in solution is 10 to the power minus 14, the pH is 14. When the pure water, the average concentration of H plus ion is 10 to the power of minus 7. This is the pH curve. So 0 to 6 it is the acidic, and 8 to 14 is the basic. So increasing the hydrogen ions, when the increasing the hydrogen ions, the neutral scale goes to the acidic. When the increasing the hydroxide ion, the neutral molecules go to the base. Then the buffer. The solution which resists the change in pH when a small amount of acid or base is added, or when the solution is diluted. This is very useful for the maintaining the pH for the reaction at an optimum value. A buffer solution is consists of a mixture of weak acid and its a conjugated base or a weak base and its conjugated acid. We have the weak acid and its salt or a weak base and its salt. So buffer helps the organism maintain the pH of body fluids with a narrow range of necessary for the life. Buffer capacity. The amount of acid or base that can be added without causing the large change in pH. The normal pH 7.3 to 7.45. The blood maintain the pH due to presence of buffer in it. So your buffer system in blood, hemoglobin and oxyhemoglobin. So name the acid base conjugated acid base for each reactions.